Hey everybody, welcome to Priority Standard 6 of Algebra 2. We are getting started here with a whole new unit, so please make sure that you have your new notes packet printed off. And we're going to dive right in with Learning Target 6.2.2, which says to identify characteristics of a rational graph. Specifically, you're going to be looking for asymptotes, domain, and range. So let's get started. Now this whole year we've been working on lots of different kinds of functions. So some of these you should remember already. Of course, we have our linear functions, these graphs that look like a straight line. We've studied quadratics, that was Priority Standard 2, graphs that look like a parabola. Priority Standard 3 was all about polynomials, so those are graphs with multiple humps and bumps. Then we took a break for Priority Standard 4, which was probability and statistics. And in our last unit, Priority Standard 5, we looked at exponentials. So for instance, exponential growth would start off with horizontal asymptote and then really skyrocket. Now we are in Priority Standard 6, and we are going to be looking at rational functions. So rational functions can have lots of different shapes, but they are characterized by having both horizontal and vertical asymptotes. So an exponential function has the horizontal asymptote, but not a vertical one, whereas a rational function would have both. So you might have two legs and a graph that looks something like this. So our first learning target here is just going to be looking at these graphs and identifying different information about them. So we're going to start off with a few different definitions here. And we've talked about asymptotes before. Your exponential equations had those as well. And that would be a line that the function approaches but never crosses. So an asymptote is a line that the function approaches but doesn't cross. And there are two types of asymptotes. We could have vertical and horizontal. So you should remember those vocab terms from geometry. A vertical line is one that runs straight up and down. A horizontal line is one that runs sideways or left and right. So vertical is straight up and down, horizontal is sideways, flat, left, and right. And then we have domain and range, which we've talked about a little bit from Priority Standard 3, finding the domain of polynomial functions. But the domain is the set of all possible x values. Where the range is the set of all possible y values. So domain is x, range is y. And then one more little tidbit that we're going to be using here in this unit quite a bit. What value can you never ever divide by? And the answer to that is, of course, 0. If you divide by 0, your function will be undefined. There is no number that you can get by dividing by 0. So never ever divide by 0. If you do, the function will just break. So looking at these different equations, we want to think about x values which would make us divide by 0. In other words, would make the function undefined. In other words, would give us a vertical asymptote. So let's break this down. If we are dividing by 0, in other words, if the denominator of the equation is equal to 0, then numerically the y value will be undefined. You'd end up with something divided, y equals something divided by 0, and you won't know what that thing is. It's an undefined value of y. So the number itself is undefined, and on the graph, that gives us a vertical asymptote. So the way that we find these x values is by saying, where does the denominator equal 0? So in this first rational function, x squared minus 8 over x minus 10, where does the denominator x minus 10 equal 0? Well, that's pretty easy to solve. All you have to do is add 10 to both sides, and then you would get x is equal to 10. So if I go back and plug 10 into this equation, I would have 10 squared minus 8 divided by 10 minus 10. That would be 100 minus 8, or 92 divided by 0. Well, 92 divided by 0, that's not a number, that's an undefined value. So if I wanted to graph this function, I wouldn't know what y value to put for an x-coordinate of 10. It would be a vertical asymptote. And same for these other functions. If I have 2x minus 6 as the denominator, I would divide by 6, or divide by 0, wherever that denominator is equal to 0. So in this one, I would add 6 to both sides and get 2x equal to 6, and then divide both sides by 2 and get x equal to 3. So my function would be undefined, I wouldn't know what the y value is, and I would have a vertical asymptote at x is 3. On this one, x squared minus 9, if I said that denominator equal to 0, that one actually factors into two pieces. So x minus 9 factors to x plus 3 and x minus 3. So this one would have two vertical asymptotes, two places where the y value is undefined. Either x is negative 3 or x is positive 3. In this fourth function, x squared plus 8x plus 15, if I set that equal to 0, to see where would I be dividing by 0, well, that factors to, oh, that's just 8x, not 18x. There we go. That factors to x plus 5 times x plus 3. So if x plus 5 times x plus 3 equals 0, then the solutions to that are either x is equal to negative 5 or x is equal to negative 3. So if I tried to plug either of those x values into the equation, I would end up with an undefined y value, in other words, a vertical asymptote on the graph. So now that we know where those vertical asymptotes come from, let's think about analyzing some of these different graphs and how do we write this out. So first of all, let's think about a vertical line. So I have an example of a vertical line right here in blue. And this vertical line has many possible different y values. I have a point on this line with a y-coordinate of 5. I have a point on this line with a y-coordinate of 2. I have a point on this line with a y-coordinate of negative 1 and negative 2, negative 5, and lots of different points in between. However, this line only has one x value. If I think about the coordinates of these different points, this point is 2, 5. This point is 2, 2. This point is 2, negative 1. This point would be 2, negative 2, 2, 5, and so on. So there's lots of different y coordinates, but they all have the same x value. So if we want to write an equation for a vertical line, it's always going to have the form x equals some number. In this case, x equals 2, because all the points on that line have an x coordinate of 2. And that confuses some people because this is a vertical line, but x runs horizontally along the x-axis. But the way that you write the equation is all of these points have the same x value. Horizontal lines, for instance, this one highlighted here in red, work the opposite way. So if I choose some different points along my horizontal line here, let's say I've got this point right there that has coordinates negative 5, negative 1. This point here is at negative 2, negative 1. This point here is at 2, -1. I've already labeled that. That's the point of intersection. If I choose another point over here, that has an x-coordinate of 5 and a y-coordinate of -1. So all of these points along the horizontal line, they have different x values. I've got an x value of -5, -2, +2, +5, and lots of things in between. Many possible x values, but only one y value. They all have the y-coordinate of -1. So their equations are going to look like y equals some number. In this case, y equals -1. So the format for a vertical line always has the form x equals whatever number. The format for a horizontal line always has the format y equals some number. So if we look at a graph like this one given here in box 3, the first thing that it asks us to find is the equations of the vertical and horizontal asymptotes. So I need to look at this graph and see where are the lines that the graph approaches but never crosses. And I see one of those lines right here highlighted in yellow going up and down. And then it also looks like right here. This is a line that the graph gets really, really close to, but never quite goes across. So the vertical asymptote is the one that is going up and down, and I have lots of different y values. I have 7 and 6 and 5 and 4 and so on, but what these points all have in common is they have the same x value, which is 2. So the equation of the vertical asymptote is x is equal to 2. Now for the horizontal asymptote, I have lots of different x values. So on this line running side to side here, I have a point at x is -3 and -2 and -1 and +1 and +2. So lots of different x values, but what they all have in common is they have the same y value, a y value of 1. So the equation for the horizontal asymptote is y equals 1. So a way that you can tell the equations of these vertical asymptotes and horizontal asymptotes is where they cross the axis. So the vertical asymptote crosses the x-axis at 2, therefore its equation is x equals 2. The horizontal asymptote crosses the y-axis at 1, therefore its equation is y equals 1. Now the other thing that rational function graphs can have is they can have holes in them. And we see this right here, this little gap, and the coordinates of this gap are at x is 3 and y is 2. So we would put that down 3, 2. There is a hole there. Now we're going to use this information to write the domain and the range. So in words, the domain is the set of possible x values. It can be any point on the number line except for a spot where there's a vertical asymptote or a hole. So the domain would be the set of all possible x values. It would be all real numbers except for 2 and the x coordinate of the hole, which is 3. So in words, all real numbers except for x is 2 and x is 3. And we have some special notation for how to write that. The first part of it can be any real number. We use x, e, and then a double barred r. And that is shorthand for x can be any real number. Then to list the exceptions, we put a vertical line, and then we list anything that x can't be. So it never crosses that vertical asymptote, so x can't be 2. And it also skips over this spot where there's a hole at an x-coordinate of 3. So we would list that as our other exception, x cannot equal 3. And then we do the same thing for the range. The range can be almost anything. I have a part that goes up here towards positive infinity. I have a part that goes down here towards negative infinity. So y can be almost anything it wants. There are only two spots that don't have a y value, and that is the horizontal equation and the y coordinate of the whole. So in words, y can be any real number except for 1 or 2. And in symbols, y is an element of the real number set, y-e-double-r, and then you use a vertical line to show the exceptions. Y can't be 1 because there's a horizontal asymptote there, and y can't be 2 because there's a hole in my graph at y equals 2. So you look for the vertical asymptotes, you look for the horizontal asymptotes, you look for the holes, and then the domain will be any real number except for the vertical asymptote or the x-coordinate of the hole. So anything except for this number and this number, here and here, where the range will be any real number except for the horizontal asymptote equation and the y-coordinate of the hole. So here and here, those are my two exceptions. And this should be y is not equal to 2. So let's look at one more example. Here, this is box 4. The first thing we're looking for is the asymptotes. And I see one line right there. It gives me a break in my graph. I see another one here. And running horizontally, I see one right here. And I don't see any holes in this graph, so that's convenient. We can just skip that whole box. But now let's look at some equations. So for my vertical asymptotes, I see this one on the left crosses the x-axis at a value of -2. The one on the right crosses the x-axis at a value of +2. So the equations for these vertical asymptotes are x equals -2 and x equals +2. And then the horizontal asymptote has lots of different possible x values, but it crosses the y-axis at a value of 3. So because of that, the equation of the horizontal asymptote is y is equal to 3. Like I said, there are no holes, there are no little spots where this graph just breaks up in a little quick way, so we can go straight to writing our domain and range. The domain can be almost anything. I have values going towards -infinity on the left and +infinity on the right. The only two x values that the graph cannot have are these two asymptotes. So x can be any real number except for -2 and +2. In symbols, x is an element of R except x does not equal -2 and x does not equal +2. And there are no holes, so there are no other exceptions. If there was a hole, we would also include its x-coordinate on this list of exceptions to the domain. Now the range, we have almost anything. I've got positive numbers going up, I've got negative numbers going down. The only thing that y can't be is the horizontal asymptote. So in words, y can be any real number except for 3. In symbols, y is in R, except y cannot equal 3. And because there's no hole, that is the only exception. If there was a hole, we would also include the y-coordinate of the hole on the list of things that are excluded from the range. So that's how you tell the vertical asymptote, the horizontal asymptote, and use those to write the domain and range. I'll be making a separate video that shows you how to type this notation of domain and range using Equatio so that you can use that on your Google Forms. See you there.